is the summary. This section will be the summary of what we have in these chapters here. If you don't like it, you can return that to me. And I will start from very beginning. In very beginning, we have three sets of the different formulations for Kepler's problem. And our first portion of the homework, we have done the exercise for this. But here, let me summarize. So here is the method one is what we have done before. So here we are given initial conditions, and we also given the time of flight. So we're going to calculate is R and V. Okay, so basically here we can utilize the elliptic orbit for example here. So for example, this is the orbit and this is the focus here. And so for example here, this one is our initial positions and velocity. And we are given this. And right now we want to know is from point A to point B. So A to B, that's spent, the time of flight is delta t. This one is given. So we want to determine what is the position R and what is the velocity V at point B. So that is the problem statement here. Okay. So from here, the first method is what we have done before. And so by all means, here we are only given the R and the initial position, initial velocities. So here the step is this. You have to determine the orbital elements first. So in this case, at least you know what is the A, what is E, and even what is omega and the true anomaly corresponding to 0. Okay, 1, 2, 3, 4, 5, and we lack one and I. Okay, inclinations. And this one again. This one, although this is falling into our contents of our second test, and I know right now most of you are doing the things by hand. I really encourage you to write a program and such that the program, you can take up the two information right away. The program can give you the 6 elements properly and correctly. You're going to use it in the final. Okay, sooner or later you're going to do it. So that is the first step. And then the second step, once we have the whole thing, then we have determined this already, then we can determine right now we're going to use Kepler's equations, and so here we can determine, for example, let me utilize the elliptic orbit for example, so we can determine E0. And this one basically is given by, do we have that equations? Let me find that equations. That one is on your handouts, the single page handouts today. And that one I'll summarize the information. So from that handouts, basically you can utilize this equation. I can calculate 0 by this, by tangent mu over 2 equal to 1 plus E, 1 minus E, and tangent is E over 2. You can utilize this equation to determine E0, okay? And so we gradually kick into, so now the step 3, So right now here you can see we have the corresponding value. Then the next one we want to progress to determine that one. So here we are knowing given data t, then we solve the Kepler's equations for E. Okay, what is the Kepler's equations? Kepler equation again is on the handouts here, and for example, the Kepler equation is this. For example, using elliptic orbit for example, and data t equal to E minus E sine E, and minus E0 minus E sine E0. Okay, using these equations, we are given delta t, and you using the numerical approach to iterate to determine the value of E. Okay, and once we have done that one, basically here you can so that one, this E is determined. Okay, so therefore again, step 4 with the E solved, then you can determine mu. So this is mu. So mu basically again using the same equations here. Okay. So once you have a new determinant, basically you have the true eccentricity. You can use orbital equation to determine R and or otherwise you can back to the formulas. Right now here you can see we have all the orbital equations, and we have all orbital elements. And so how to determine that one? If you remember in again, that is in our content of our test. If you remember our equation, we can describe the positions in PQW perifocal system, and that one can be described by this. That one is R times cosine mu, R times sine mu, and 0. Okay, again, this is on our cheat sheet. Hopefully you still have that cheat sheet, and let me write it out for you here. And V in PQW, on our cheat sheet we have these equations. Mu over P minus sine. Okay. And once we have done this, pretty much we solve for these questions, and we have the final destinations. And if we wish to express the position velocity in terms of the ijk, then we know we have the conversions to the transformation. We have that formula. Okay, so we can rely on. You can refer to the cheat sheet and to convert to. Available to transform to R ijk and V ijk. Okay, so basically this one is on our cheat sheet, or that is available in our textbook, right? Okay, so that is the procedure for this. And so we can take a look at the, so basically this handout is to summarize the old approach. Really depends on the first step. In the first step, you can determine right away what kind of the orbit you are dealing with. And for this illustration here, I assume we are dealing with is elliptic orbit. If we are dealing with different types of the orbits, basically the equation summarized in this handout is available to you. Okay, and today we have a handout there on the table. So that is the first method, and that probably you can